So here we go. It hasn't turned red yet. There we go. All right. So first question, and when I pull up homework questions, this is the way it looks since we haven't gone over any homework questions yet. Got two questions to go over. This is called the review question. There's the section. There's the number in the book. If you was to go to the review section in the book, it'd be like number 13, and it's in your homework, number 23. Okay? So this is review question, section 5, number 13 in the book, number 23 online. So let's look at it. Okay, this question says -25 to the 1/2 power. Okay, now I disagree with this question because you can't take the square root of a negative, but the way the question is written, I think it would be better if they put parentheses around it. I'm going to show you two options. Okay, the way it's written right now, the answer is not -5. Okay, the way it's written right now is the square root of -25. That's the way it's written right now. Now, the way they're wanting you to read it is like this. That's the way they're wanting you to read it. Now, if it's written like this, like they've got it, then the answer is the square root of 25 times the square root of -1. The square root of -1 is I. The square root of 25 is 5. That's the answer. Okay, now they say the answer's wrong, and I disagree with this question because the way they have it written, without parentheses around it, leads me to that. They are wanting you to do it this way. And that would be negative parentheses square root of 25, which is -5. So for homework, because I wouldn't put this one I would never put this one on the test because it's a tricky question. This is what you need to do for homework. Okay? Are we getting, I bet you $1 we're not going to get any skips this morning. Now I want to ask y'all something because I don't want these people to think I'm crazy. Have we been having problems with skipping and freezing? Yes or no? Raise your hand if you've been having, raise your hand right now. Please. Yeah, okay, they're just saying yes. Okay. All right, I just want, and did we have this yesterday, which means Monday? Did we have skipping and freezing Monday? Raise your hand if you did. Or yes. So I'm not making this up. And guess what? It's not doing it today, is it? Bet you $1's not going to do it. It happened every day. Has it happened every day? Let's see, we've had Monday, Wednesday, Friday, and Monday. Has it happened every day? Yes. And of course, it's not doing it today. And it won't do it, probably, since we got IT sitting in. It's kind of like having the doctor show up and nothing's wrong when the doctor or the mechanic shows up. All right, so we'll just blame it on the Russians, I guess. Everything's the Russians' fault. Next question. I'm going to delete that one. This question is R3, number 53 in the book, number 14 online. Okay, this is the shortcut number 5. This is shortcut number 5, which is a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. So you got to take the cube root. A cubed is equal to 64x cubed. B cubed is equal to 1. Take the cube root of everything. A is equal to what? 4, Hubert, right? And B is equal to 1. And plug and chug. 4x minus 1 times 16x squared plus 4x plus 1. That should be your answer. Let's check it just so we can check, see if Hubert knows what he's doing. And the answer is 4x minus 1, 16x squared plus 4x plus 1. Ding! So everybody feel good about themselves? All right. So that's the homework questions that's been sent so far. Let's go back to the review and pull up and see where everybody is, or not everybody, see where, where we left off. tctc.mylabsplus.com, pull in 110, and let's pull in the review homework. How far did we get the other day with the review homework? Anybody write down how far we got? Y'all settle down. Y'all keep it quiet now. Nobody's gonna say anything. All right, I think we got to the shortcuts, right? I think we did domain. Now y'all gotta help me out because 109 and 111, we're doing some of these same problems, so y'all gonna have to help me out. Did we do this one, trinomial? Did we factor that one? I believe that was the last one we did. Somebody speak. Yes. Okay. Did we do this one? Okay. I don't think we did this one. We might have. I think we did. Did we do this one? Yeah, that was the last one we did. Okay, -8 to the third power. I don't think we did this one. Yes or no? We did. Okay. Okay, we got it. We did and no. Which one is it? Okay, no, we didn't. We did. Okay. I'll do it just in case. All right. How about that? So this is an exponential. This is a aesthetic. Why is it aesthetic? Because you don't like negative what? Exponents. So this is over 1. So flip it, and that becomes 1 over -8 to the third power. And I have no idea what 8 to the third power is, but 8 times 64 would be what, 512 or something ending 2. What is it? Somebody tell me. What's 8 to the third power?
512.
Okay. So your final answer is -1 over 512, if that's the way they want it. It says it's a simplified fraction, so that should be your answer. Does anybody know what the most common problem with this problem is? Does anybody want to take a stab at it? Have we had any pauses or freezes or blips? Of course not. The reciprocal swap, the negative, they try, this is what happens. Y'all try, students, when you bring that -8 to the third power down, y'all think it changes the negative to a positive on the 8, and it doesn't. Because if that was true, you could change your balance in your bank account from -500 to 500. Wouldn't that be nice? Okay? You can't change a negative by just bringing it downstairs. You can change the exponent, but you can't change the quantity. Next. Darn, we need to go into another section today. I didn't know we were that close to finishing. All right, this one says, okay, I would change this to 3/1 to the -5th power, that'd be to the +5th, and 3 to the 5th, 3 to the 2nd, 3 to the, I don't know, 3 to the 5th, that'd be 81, what is it, 243? Thank you. Next question. This one right here, we went, I believe this is the last one we did, so I'm gonna skip that one. That would be 2 to the -14th, which would be 1/2 to the 14th, and I'm not even gonna try to do 1, it'd be 1/2 shift up to the 14th. And 25. Now this one you can do several different ways. This one you can actually flip these two and make this a positive. I wouldn't do that. I would go ahead and distribute the negative and make both of these positive. That's what I would do. And that's going to be R to the 6th power. So R to the -2 over S to the -3 raised to the -3rd. That's going to give us R to the 6th over S to the 9th. That's it. So that was a pretty simple question. So you would type that in, R, let me turn on my mouse, R shift up to the 5th over division S shift up 9th. Okay, I've got something wrong. 2 times 3 is 6. 3 times 3 is 9. Okay, I have no idea. I don't know, did I? Oh, I said 5th right there, it's 6. I don't know why I did that. Thank you, Mr. Stiles, I appreciate that. You ain't kin to AJ? All right, next. Oh, that's it, that's the review. So let's move on to 1.2. So now, everybody should be able to finish 1.2. Capiche? I'll give you like one more day to send me questions on 1.2, but after Friday, after Friday, the review is toast, okay? Unless the procrastinators, they'll try to send me questions next week as we're getting ready for the review test or whatever the case may be, okay? So that's the review, it's done. So Friday after Friday, questions done. 1.2, what are we going over in 1.2? Let's look. This is where we talk about interval notation. Let's see, what else we talking about in 1.2? Interval notation, set builder notation, graph the equation, Okay, looks like we're going over domain range functions. So what I'm going to do is I'm going to hit the whiteboard and give y'all a little rundown of functions. So here we go with the whiteboard. I want to start off with I want you to get a sheet of paper, and I want you to turn it on its side, landscape. And I'm going to make, let's see, I want to bring in, let's see if I can do that with this. Yeah, there we go. All right, y'all should see graph paper. I want you to take your ruler, and I want you to draw a line across the middle, like this. Then I want you to draw at least 10 small boxes, like this. Now mine, I'm making mine real small because I'd like to have at least 12. So I'm making them a little bit smaller than normal. That's 12, that should be 12. Okay, this is called parent graphs. Now this is going to follow you. It's kind of like the shortcuts in reverse FOIL. It's going to follow you like forever until you're out of math. So if you're a civil engineering major, and you've got to take thermodynamics, statics, dynamics, thermodynamics, you're going to be following these graphs and these shortcuts and completing the square and calculus. You're going to have it for another 5 or 6 years. Okay, so you need to learn them. If you're in underwater firefighting, then you're probably not going to need this after this semester. But not many people that take college algebra are in underwater firefighting majors. All right, the first one is going to be called linear. And that's when f of x is equal to x to the first power. And that's going to give you a linear line, meaning a straight line. Now, of course, most of you know that because you've had pre-algebra and algebra 1. You know that. I mean, I'm not going to insult anybody's intelligence. I'm just going to make sure everybody understands that these are the basic models of each degree polynomial. F of x is equal to x squared. That gives you our parabolic function. Dang old parabola. That's what I called it first day of class in Math 110 in Dr. Gabati's class. I called it a parabola. And Dr. Gabati goes, Mr. McClure, I do not understand what you're saying. I said, that's a dang old parabola. And he changed it and told me that I was saying it wrong and it was parabola. So make sure you don't call it a parabola. F of x is equal to x cubed. That is a odd function. There's really not a name for it. You can call it a cubic function. Now these two, I'm going to put f of x is equal to x to the fourth, but I'm going to say x to the even. And I'm going to put even in magenta. Because what happens when you have an even exponent, not only is it even, meaning symmetrical around the y-axis, but the higher that number gets with the magenta, the higher even exponent you get, the more square your parabola gets. And I'm going to take that magenta and I'm going to draw a kind of a square right here. The more that index goes up, the more the E, like 6, 8, 10, 12, the more your parabola starts to square off on the bottom. F of x is equal to x to the 5th or x to the odd. And I'm going to put that in magenta. Okay? So that means that we've got a odd function which is symmetrical around the origin. And in this case, the higher you get with the odd exponent, the more you start to see the squaring off there. Okay, so it starts to look more like a saddle. Okay, starts to flatten out instead of straighten out. And that's important for you to understand. Odd, as that goes up, that flattens out, and even, that flattens out. Okay, on this one, absolute, absolute value, absolute vodka. So what does that mean? What does the absolute value function look like? Well, what does vodka and value start with? V, Hubert. That's right, class. Thank you for the interaction. So your function is going to look like a V. F of x why does it do this in this left corner? Well, at least I got the IT people seeing this. F of x, I have to stand away from the board. F of x is equal to the square root of x. That's just a swoosh. And it doesn't have another side because you can't take the square root of a negative. F of x is equal to 1 over x. That's going to be your half a volcano. Looks like half a volcano. And then f of x is equal to 1 over x squared is your full volcano. Looks like a volcano. Now, there's 3 spaces left for later. When we get to exponentials and logarithms, we'll put those 3 in there. This is a very important page because you get to see the basic model. The basic model of x to the first is a line. The basic model of x squared is a parabola. The basic model of x cubed is that, and so on. So when I show you a polynomial, you know what the graph looks like just because you've got the sheet in front of you. This is a very important sheet. I would not lose it. You're going to see it again in calc. Okay? Especially with the logarithms. These 3 down here, you're going to see a lot of them. All right, so with that being said, let's move on to the next page. And I'm just going to go over a little bit of graphing. Are we running into any skips or freezes or anything? I want you to tell me why last week they were having all these problems and now they're not a little bit. Okay, where are you, Mr. Malota, where are you from? Where are you calling from? Charleston. But I say I've got a student in the next class from Charleston. I've got a student in Sumter in my And they didn't have any problem with, I don't know about the one in Charleston in the next class. But how bad is it compared to last week, Mr. Malota? Not as bad. So I guess I look like a dang fool. Thanks a lot, Math 110, for making me look stupid. I don't have to do much. I have to just walk fast. But anyway, let's go ahead and talk about graphing. There's two things about graphing that you need to remember. Okay? What the heck?
Tell me that don't look bad.
No, look. Well, I'm glad you're sitting in my class so you can see that sometimes stuff like this happens. Battery fell out, sorry. Yeah, that one's dead on the doornail. I hadn't used it but a week. So, all right, so with graphing, you got three types of graphing. Method one, this is a chart plot. Chart plot method, you solve for y. Y is equal to 2x plus 3. And you draw 5, -2, -1, 0, 1, and 2. If this is a fraction, you pick multiples of the denominator. So I'm going to do another one over here. Y is equal to 1/2 x minus 2. I would pick x, y. I'd pick -4, -2, 0, 2, and 4. If that was a 3, I would pick -9, -3, 0, 3, and 9. Okay. Plug and chug, -2, that'd be -4 plus 3 is -1. -2 plus 3 is +1. 0 plus 3 is 3. 1 be 5. And 2 times 2, that'd be 7. Over here, -4 divided by 2 is -2, that'd be -4. -2, that'd be a -1, -3, -2. You start to see the pattern. -1 and 0. And you plot the points. So the first line is -2, -1. -1, +1. 0, 3. And 1 and 5. 3, 4, 5. And 2 and 7. And of course, you see that you got a line like that. And then -4, -4. -2, -3. -0, -2. And you got a line that looks something like that. Okay, everybody should say, yeah, I know how to do that. I remember that back in pre-algebra, or, you know, what does that say? You can show them the glitches in the recording. So it does show up in the recording. Is that what y'all were saying? I need to show you the recordings in and see if you can determine what it's from. Because I know what's going to happen. Y'all are not going to be in here Friday and it's going to go back to doing it. That's what's going to happen. All right, so this is method one, chart plot. You do it when y is by itself. Go to the next method. Oh, one other thing. Take our highlighter. What is the, by the teacher, what is the domain of this function? The domain of this function is -2 to +2. The range is -1 to +7. Now, what does domain and range mean? Domain is input. And if domain is input, what is range? Output. If domain is the independent variable, then what is output? the dependent variable. So the domain on this one by the instructor, because that's the ones I picked, is -4 to +4. The range is -4 to 0 by the instructor. Now we're going to get into that, by function. By function, they're all real numbers because you can plug in anything. But we'll get to that in just a minute. Got to keep watching the time. What time is it? Not a single clock on one of these screens. It's 9:46 because these students will have convulsions. I don't know if you know that, Sandra, but they start having convulsions.
You do.
Oh, you do? Okay. Oh, you're not helping me out, Sandra. All right, method 2. Method 2 is called the intercept method. Intercept method. Intercept method is used a good bit, but not a lot because some teachers don't show it because they have to teach you how to do it, and they don't like doing that. So when do you use it? When y is not by itself. And that's 2x plus 3y is equal to 6. And I'll just tell you right now, we're going to put it in a box like that. We're going to put 0 for x. And over here, 2x plus 3y is equal to 6. 0 for y. 0 for y is our x-intercept. 0 for x is our y-intercept. And that's true in marketing, chemistry, biology, business, physics, math, calculus. If you want the x-intercept, you plug in 0 for y. If you want the y-intercept, you plug in 0 for x. Okay? So plug in 0 for x, and that takes that term out. And you're left with 3y is equal to 6. Y is equal to 2. Over here, you plug in 0 for y, and it knocks that out. And you're left with 2x is equal to 6, x is equal to 3. And you plot those points, and that's your line. Now, I am going over a review, these two sections, so hopefully all of you are going, oh yeah, I remember that. I know how to do that. That's great. Okay, the next one is building a line. Now, this one is the one that most teachers teach because they don't have to teach you how to do math. And that's why they teach it to you. And that's building a line, method 3. Build a line. Build a line. First thing you do is y is by itself. That's when you use it. I tell students it's also a good time to use it if you have a fraction, although you can use method 1, but if you have a fraction, this one is best. So y is equal to 2x plus 3. Extract your info. My y-intercept is 0, 3. My slope of my line, my slope is positive m, so that means left to right, up. And then 2 over 1 is my vertical over my horizontal. Now go to my graph, and I plot my y-intercept. And then I draw my trace line, left to right, up. And then I do 2 over 1, 2 down, 1 over, 2 down, 1 over, 2 down, 1 over, 2 up, 1 over, 2 up, 1 over. And there's my line. Now, all of these lines, all of these methods, you should be saying, oh yeah, I remember doing that. Remember, the first method The first method is the way that you do nonlinear. The first method is the most used. Okay? All right. So, with that being said, what is the domain and range? Well, I can tell you this, and I'm going to shut up. What time is it? Tell me what time it is, please. It's what? 9:51. I got 4 minutes before they start convulsing. All right, so we've got, or does class end at 10? Class ends at 10, right? Okay. All right, so what I'm going to show you here is mostly all functions has a domain of all real numbers. Okay? Why isn't it 100%? Because we have things like radicals with an even exponent. And what can you not take the even exponent power of? A negative. So therefore, the domain is affected. Okay? Since we can't take the even root of a negative number, the domain is affected when you have a radical with an even exponent or a rational, because you can't have 0 in the denominator. Can't have that. So when you have functions that you can't have a number in, you can't take the log of a negative number. You can't do that. Okay? What are we talking about? The word can't. When you have a function, and that function has a something can't, you can't use blah, blah, blah in this function, then the domain is going to be affected. Okay? So, I can't put a -3 in an even exponent. I can't put a 0 in the fraction, and I can't take the log of a negative number. So all three of those functions, when you see one of those, the domain is going to be the domain is going to be affected. Okay? So how do you know? Well, you set whatever you're testing, you set it equal to 0. So if I've got the square root of x minus 5, I'm going to set x minus 5 equal to 0. If I've got 1 over x plus 6, I'm going to set x plus 6 equal to 0 and solve. If I've got the log of x minus 3, I'm going to set x minus 3 equal to 0. And then I'm going to graph it and say, what numbers can I not use? Okay, my audio's cutting out. Was that just it? Okay, audio's cutting out a little bit. Okay, anybody else that cutting out any? It's fine for me, of course. Yes, for Cruel. Cruel, where are you calling from? And Parisi, where are you calling from? Greenville and Clemson. Okay, well, all right, I'm going to go ahead and shut her down right now because, one, let's see, what time is it? It's 9:55, and I want to look at the recordings before you leave, if you don't mind, so we can see what it looks like, okay? All right, I'm glad the recordings do show it so people won't think I'm crazy. All right, so the first thing I'm going to do is finish the presentation, and I'm going to cut off the recording, and I'm going to take the roll